Hello, this is Ann Carlson, a mathematics consultant with the Ohio Department of Education in the Office of Curriculum and Assessment. The purpose of this presentation is to describe the first steps in designing curriculum and instruction that will meet the rigor and expectations of the Common Core State Standards for Mathematics, Ohio's adopted career and college-ready standards. The documents for this presentation can be found on the Mathematics webpage, most under the heading Alignment Toolkit Phase 1 Gap Analysis. Awareness begins with familiarity of the structure and intent of the Common Core. Analysis requires comparing the meaning of the standards with your current practice. Alignment results in a realization of the necessary changes. In order to design instruction that meets the rigor and expectations of the Common Core, understanding the mathematical practices and the critical areas of focus, or critical areas, are essential. This equation is a reminder that having a strong working understanding of the mathematical practices and the critical areas of focus will lead to more rigorous instruction. Targeted Professional Development 2 focused on these areas. This PowerPoint and documents are posted on the Mathematics webpage. In both Targeted Professional Development 1 and 2, time was devoted to understanding the meaning and purpose of the standards for mathematical practice. It is through orchestrated, intentional experiences of reading, writing, talking, listening, and reasoning mathematically that students will develop the mathematical habits of mind, allowing them to connect mathematics to their daily life and career situations. The critical areas of focus inform instruction by describing the mathematical connections and relationships students develop in the progression at this point. Where are the critical areas of focus found? On the introduction page of each grade level or course. Understanding of the critical areas of focus is essential in developing the context of the big picture of what students should know and be able to do. They more fully describe the breadth and depth of the learning at this point. One of the advantages of adopting national standards is having colleagues across the United States working on the same initiatives. New York and Oregon have developed a PDF describing the 6 shifts in mathematics. If you have not seen this Prezi authored by Brian Roget, then I suggest you view it. It is a creative way to quickly review these 6 significant shifts between current instruction and instruction geared toward the Common Core State Standards for Mathematics. Once an awareness of the mathematical practices, critical areas, and the 6 shifts is developed, then analysis of the specific changes in the content standards is next. This is a sample of the mathematics gap analysis. The full band rows highlighted in red provide the critical area or critical areas of focus, domain, and cluster perspective for each of their related content standards. What? The gap analysis is a tool to use in analyzing the differences in current instructional practices and the intent of the Common Core. Why? To facilitate understanding of the needed changes. When? Prior to mapping curriculum into year and unit plans. Who? Teachers, curriculum specialists, and others involved in student instruction. Prior to completing the first columns of the gap analysis, it is helpful to think about the big ideas described in the critical areas. What are they? What is the evidence students would demonstrate to prove their understanding? And what are common misconceptions? If not completed here, then it would also serve as a refresher prior to mapping curriculum. The first 3 columns of the gap analysis ask for a determination of the degree this content is currently taught, highlighting specifically what needs to be added to meet the full intent of the Common Core. This is not just a comparison to the Ohio Academic Content Standards, but also a decision based upon current instructional practices. The last 2 columns require decisions about the level of the thinking required by the content standards. This is founded in the cognitive demand. Cognitive demand represents the type of thinking, or the level, depth of complexity of thought expected. The framework to make this comparison is the cognitive demand categories for mathematics, used in the surveys of enacted curriculum. Many of the Common Core state standards for mathematics content standards embrace multiple levels of cognitive demand. A careful analysis will address all levels. Once this process is completed, revising curriculum begins. This process is covered in the next presentation: analysis, mapping, recording. Often the actual language of the Common Core state standards for mathematics causes questions. To find answers to those questions, several resources have been posted on the mathematics webpage. The model curriculum is a start, but is not comprehensive. Looking at the narrative descriptions of the learning progressions developed under the direction of Bill McCallum is a great source for seeing the picture more clearly. Other resources listed as web links on our resource document. Please contact me with any questions or comments about this process or presentation. Thank you for joining me.